anatomy of the if statement. The if statement or syntax is relatively simple. You've got three components of the formula: your logical test, your value if true, and your value if false. Your logical test is basically any test that results in either true or false. So you could say test that the value of A1 equals Google, or that the numerical value in B2 is less than 100. You could also incorporate more complicated formulas here. You could say if the max value in column A is between 25 and 30, and so on and so forth. It's literally an infinite number of tests you could put here. Next, you've got value if true. This is what you want Excel to return or to do if your test proves true. So you could just put a number or a text string here. You could also put a formula, in which case Excel would evaluate that formula if your logical test was true. And then, as you might expect, value if false does the same thing. It's what you want Excel to do in the case that your logical test is false. So let's jump into Excel and do a hands-on demo. Open the Section 3 Logical Operators document, and we'll work from there. Just to give you a quick background of what we're looking at, we've got weather data from a station at Boston Logan Airport. Don't pay too much attention because I made up some of these numbers, but you get the idea. We've got latitude, longitude, date, and month. We also have temperature and precipitation in Fahrenheit and millimeters, respectively. And from that basic information, we're going to be building out additional categorical variables like freeze, climate, precipitation type, conditions, etc., using logical operators in the rest of this section. For this lecture, we're going to start with column I, the freeze column, and all we want to do here is say, let's create a flag or binary variable that equals yes if the temperature is freezing. In other words, if it's below 32 degrees Fahrenheit. Otherwise, return no. So I'm going to use an if statement to do this. We're going to take it nice and slow for the first time. Basically, I'm just going to type equals if and open the parenthesis. As you can see, this little helper box has popped up. You can see the three components that we just talked about. And again, the first thing I need is the logical test. So I'm just going to arrow over to G2, which is where my temperature field lives. Type the less than 32. So that's my test. I'm going to hit comma. Now I need to input the value if true. Since I want text here, I need to surround it in quotes. I'm just going to type yes. Comma again brings me to the value if false piece. Same idea. I type no, surround it in quotes, and close the parenthesis. So you'll note that I left my reference to G2 completely relative as opposed to fixing it. And that's because when I apply this formula down, I want my reference to change from G2 to G3 and G4 because I always want it to refer to the proper temperature in the proper row. So as you can see, I double-click the lower right corner of the formula cell, and it has populated all the values down as far as there's data, which is exactly what I want. Now just to kind of spot check that it's working properly, as you can see we have some cases of missing data and NA values. Don't worry, that was intentional. We'll deal with that momentarily. But based on the values that I do have, 37 degrees is no because it's above freezing. 12 and 23 are both below freezing. It all looks good. So there you go. Basic example of using the if statement. Realistically, your test may not be quite as simple and straightforward as the example we just walked through. In many cases, you have tests that include a number of different criteria and a number of different potential values. When that's the case, you're going to want to use nested if statements. The good news is that Excel makes it really easy to do this. You can include multiple logical tests within a single formula. And if you know the if formula syntax, then you know how to use nested if statements. So let's look at an example before we dive into Excel. Basically, we have another logical test here based on the temperature field in column B. But instead of just saying, is the temperature less than 32, yes or no, we're asking two questions. We're saying, is it less than 40? If not, let's see if it's greater than 80. If not, return this otherwise value of false error. So in this case, we have three potential results as opposed to 2 in our first instance. So basically, the syntax should look familiar. You start with your logical test, b2 is less than 40, your value if true, so in this case, if your test is true, if your temperature is less than 40, climate equals cold. Now here's the catch. When you get to the value if false piece, here's where you start your next if test. And basically, what that does is it tells Excel, alright, logically work your way from left to right through this formula, and continue until you either find a test that evaluates as true, or you get to the end where your value if false value lives. So in this case it's saying, alright, is B2 less than 40? Yes or no? If it is, we're going to call it cold and stop there. If it's not, we're going to move to our next test, which is our temperature greater than 80? Yes or no? If it is, call climate hot and stop there. Otherwise, move on. And in this case, if you get to the end, if you have a temperature between 40 and 80, like 55 for instance, both of these are going to evaluate false, and your cell is going to return the value if false error, or the value of false value of mild. So let's dive into Excel and get our hands dirty. We're going to be working with column J, the climate column, and basically I want to do exactly what I just described. So I want to create a nested if statement to categorize climate as cold if the temperature is less than 40, as hot if the temperature is greater than 80, and mild otherwise. So I'll start with my equal sign. If, open the parenthesis, logical test, just like before, G2 is less than 40, value of true is going to be cold. Now, value of false, rather than just saying hot or other here, I'm going to start another if statement. If the temperature is greater than 80, value of true, hot, in quotes because it's a text string that I want to return. And then I get to my final value if false. So if I'm done incorporating all of my tests here, and I'm ready to kind of populate my catch-all value if false message or value, I'm just going to enter that here. So it's going to be mild. And now, here's a really important note. When I add the next parenthesis, you'll see that it's orange, and it matches with the orange parenthesis, which is part of my second if statement. What that's telling me is that I'm not done with this formula. I haven't closed out all of my parentheses. So when I add the second, you'll see that it will be bold and black, and it matches with the first parenthesis at the beginning of my formula, which tells me that I'm done, and I can press enter. So again, I'm going to leave the references relative, so that when I populate this formula down, my references will change from row to row. So let's see if this worked. We've got a bunch of cold values. Temp is below 40 in all of those instances. Here's a mild value, 43, that's correct. You can see that this is ordered by month, where 1 is January. So I may have to scroll a bit before I start getting into the hot values. So here's one in August, 85 degrees equals hot, 75 is mild. So it looks like it's working properly. There you go. Basic example of using a nested. Alright, so by this point you're probably a master of the nested if statements, which is fantastic. The thing is, those statements were still based on pretty simple if this then that statements. What if we need to create a logical test that's based on a number of different fields or variables, as opposed to just temperature, for instance? One great example of this is if we wanted to create a field called precipitation type. And precipitation type can take a few different values. Let's say we want to categorize it as snow, rain, or none. If you just think about it for a minute, there's no way to define snow, rain, or none based on just a single field, because it's a function of two things, the temperature and the amount of precipitation. So if nothing's falling out of the sky, precipitation type will always be none. If precipitation is greater than 0, meaning something is coming out of the sky, we need to know if the temperature is above or below freezing, to understand whether that is rain coming down or snow coming down. So that's where the and or statements come into play. It's when you need to include multiple logical tests that are based on a number of different criteria or variables. So just continuing on with the precipitation type example, you'll see that the syntax is a little bit funky. It can be a little tricky to get used to. From a readability standpoint, it might seem to make more sense to say if condition 1 and condition 2, then. In this case, Excel kind of flips it, and it always starts with if and, or if or if not, and then lists your criteria within parentheses. So reading through this example here, this and statement, basically what we're saying is logical test 1 is if these two things are true, so if and D2 equals yes, which that's our freezing column, which tells me that the temperature is freezing, it's below 32 degrees, and C2 is greater than 0, so precipitation is greater than 0, then precipitation type equals snow. Now if you remember the nested if syntax, instead of the value of false, we move right on into our second logical test, which is another if and statement. In this case we're saying if and D2 equals no, so it's not freezing, temperature's above 32 degrees, and also precipitation is greater than 0, then precipitation type equals rain. And you're always going to wrap it up at the end with your catch-all value if false value. In this case, it's just going to be none. So in order for this test to be true, both of these conditions need to be true because it's an and statement. And then if none of these are true, it's going to return the final value, which is none. And now what if we wanted to create an additional field called conditions that are either equal to wet or dry, and the conditions are just based on precipitation. So if precipitation is none, we know that the conditions are going to be dry no matter what. If the precipitation type is rain, conditions are wet. But if the precipitation type is snow, the conditions will also be wet. So we could say if precipitation type is rain, then wet. If precipitation type is snow, then wet. Otherwise dry, and do it like a traditional nested if. Or we can get a little bit more elegant and introduce an or statement to do the same thing. So in this or statement, we're saying if or, and then listing our two conditions. Basically, this is saying if either one of these is true, then we're going to return the value of true, which is wet. So if the precipitation type equals rain or it equals snow, then conditions are wet. And then again, your catch-all value if false is going to be dry. So it will return those two values. Quick tip here, when you're writing nested functions, especially if you have a number of different logical tests all stacked together, you can just copy and paste pieces of your formula to save yourself some time. So rather than rewriting if and if or statements from scratch, just copy and paste and build your formulas that way. So let's bump over to Excel and actually walk through these examples hands-on. So again, I'm going to use the exact same conditions that I just laid out. I'm going to start with equals if, parenthesis, and, parenthesis, and then list my two logicals that must both be true. So freezing equals, I'll start with yes, and precipitation is greater than 0. Close the parenthesis because that's my full and statement, and then comma to my value of true. So if both of these are true, what's the deal? It's freezing, there's stuff falling from the sky, so the precipitation type is snow. And now I'm going to start with my second one. Again, I could go up here into the formula bar and copy this chunk and paste it. I'm going to type this one out just to kind of walk you through it one more time. And then later in the sections, we're going to start to do some shortcuts like that. So value of false, remember I have one more condition to test before I do my catch-all value. So I'm going to do another if and statement. In this case, I2, the freezing field, is going to be equal to no, so temperature is above 32, and precipitation is greater than 0. Close that out, comma over to value if true for this test, and that's going to be called rain. And my last comma gets me to my final value if false. So it's if none of these tests are true, what do I want to return? And I just want none here. And then again, you need to close it out with 2 parentheses. I can tell that I'm done because I got the bold black parenthesis closing out my entire formula. Hit enter. Just like before, I used relative references, so I can just double click and apply this down, and it will update automatically. And then, one way to check my values, I can just look at the filter and see, okay, all 3 of my potential values have populated, none, rain, and snow. I'm also getting an error value because, as we talked about, there are some blank and missing values, which we'll address momentarily. Now let's quickly do the conditions field. This is the OR statement. And again, the conditions that must be true are that either the precipitation type is snow or the precipitation type is rain, in which case I'm going to call conditions wet, otherwise dry. So equals if or 2 conditions are K2 equals snow, remember in quotes because I'm dealing with a text string, comma to my second criteria, which is K2 equals rain. Close out my OR statement, comma over. If either of these are true, what value do I want to return? That value is wet. And then again, if none of those are true, my value if false is going to be dry. Put it in quotes, close it off, hit enter, and apply that down just like I did in the last example. And as you can see, I'm getting both dry and wet values. If I just do a quick spot check, anytime column K is none, I'm seeing a dry value, and then snow equals wet, rain equals wet, everything looks good. So there you go. That's a quick example of how to use AND and OR statements to develop